Okay, so the method of sections is about splitting your truss into a section and then reviewing this section as a piece in equilibrium. So you're looking at the vertical, you're looking at the horizontal forces, and you also can take moments about a particular point. Now what you'll find is that when you, like, so far you've had, with method of joints, you've got three steps to go through. Firstly, find out what the reactions are. So you'll be taking moments, usually around 2 of the reactions. You have to guess the direction of the reaction. If you get the direction incorrect, it means that your answer will be a negative. So therefore you just know that you've got your arrow the wrong way around. Then secondly, when it's the method of joints, you've just got to go to any location where you have 2 or 1 unknown, and then you can resolve around that individual joint. And then you look at horizontal and vertical, and you do like a simultaneous equation to work out what the individual members are. Again, you have to guess the direction of the arrows within the individual members. So if you have a member like that, and if we have our arrows pointing outwards, if they're pointing outwards, is that member in tension or compression? That's right, it's not tension. The reason being is that the external forces are pushing inwards, and this member itself is pushing out on the external forces. So when you're guessing your arrow directions, again, when we end up with when we look at our members, this one here is pointing inwards, so it's pulling inwards. So therefore this is under tension. So pointing inwards is tension. So it's guessing that in this case that all of these 3 are in tension. If you find out again that your answers are negative, then it just means that you've guessed your arrow direction the wrong way around, and where you're guessing that it was in tension, it's actually in compression. It's the main error that people carry forward if they guess the wrong arrow direction, and when they end up with a minus value, they then carry that incorrect arrow direction forward. You've got to make sure you don't do that. So method of sections. So here's an example here. Like within the assignment, if you're given a question and it doesn't say do the method of joints or method of sections, you can choose whichever one you want to do. However, if you had a question here and you had to work out what BD was, BE and CE, we'd be slicing through the middle. Now you could work out all of the reactions and then work out all the individual values, but you'll find that the method of joints, it's easy to work through, it just takes a long time. The method of sections, the difficult part is to try and sort of figure out where to slice the actual truss, and then where to take moments about to try and remove forces so that you can actually solve for this. Are we concentrating, guys? Yeah. Quite often you'll know what the external forces are, so you'll know what P1 is and P2. If we slice through the middle, and we just take the left hand side, we ignore the forces that are in the individual members that we haven't cut through. As soon as you cut through members, you've got to consider them as external forces. So wherever you cut through again, you make BD a force BD. So essentially you're saying that they're like external forces. And then it's about taking moments or doing any of your equilibrium equations to try and work out what the unknowns are. So normally in a question you would know what P1 is and P2. So if we were to look vertically, we've got P1 coming down, P2 plus FBE sine that angle. those are horizontal, so you just ignore them. Or if you look in a horizontal direction, you would ignore these two because they're coming downwards. And you've got FBD plus FCE, and then plus this FBE, and again, because that's your hypotenuse, so it'd be cosine this angle. But you'll end up with an equation with three unknowns whenever you're looking at sort of horizontal or vertical. The best way to try and remove some of these unknowns is by taking moments. Now, if we take moments around this point here, what we do, because we've got moments is force times the perpendicular distance. P2 we ignore because it's passing through that point. FBD we ignore, and FBE we ignore. So if we're taking moments around there, we've just got this distance times by FCE equals that distance times by P1. So you'll end up with a formula there with just one unknown, so you can work it out. Once you know this one, you can take moments around any point. When you take a moment, you don't have to take it about a point on the truss. You can take moments around a point anywhere where you find that where concurrent forces are actually passing through. So if all of these arrows were pointing to this point, and if you took moments around this point, you would ignore them, because again, any arrows that are passing through the point, you ignore them. But in order to work out these two, if we took moments around E, we would ignore this one here because it's passing through, we would ignore that. So we'd end up with a formula where we'd be looking at P1 times by the perpendicular distance plus P2 times by this distance here, and then you've got this FBD times by our perpendicular distance again. So we would have already worked out this one. We've now worked out what BD is, and because you know what these two are, you could then do the sum of forces horizontally and work out what this final force in BE is. We'll go through a few examples today, just so that you can get an idea of how to address these questions.